So this problem is similar to the fountain and gazebo problem. So imagine this is your fountain, this is your gazebo, and then you have the electrical line that already exists that is right here. You need to get from A somewhere onto this line and back to B in the minimum distance. So I think the shortest distance would be to go from A directly across to this point, B directly across to that point, and that's your minimum. However, I think the intent of the problem was to get just one situation here, so you could have A to X to B, and you want that to be the minimum. So if you put some point on here, you could kind of play around with that a little bit. If we constructed a point on the axis and then can measure this distance. So there's the length of AC. Measure this distance. So there's the length of BC, and then I can calculate. I can add those together. So take the length of BC plus the length of AC, and as we move point C around, you can notice that this value is changing. So I want that to be as small as possible. So as I'm moving it around, eventually I'll get to a minimum. Looks like 14.87 around right there was where that point was at. So how did we actually come up with that point? If I take point B, I can then mark the mirror as this, and then I can transform. I can reflect it across that line. That gives me B prime. So this segment, I'll construct this segment. So from A to B prime, the shortest distance is going to be that straight segment. That's clearly from A to B prime. That's the shortest distance possible. You're not going to branch off in some other direction. We want to go directly there. The distance from A to this point, and let's go ahead and construct a point right there to get a little more precise. I'll move point C out of the way. From A to D, or A to the axis, we have this, and then from D to B prime is going to be the same as the distance from D to B. Both of these points are equidistant away from this x-axis, so I can just kind of verify here. Measure this distance, there's the length of DB, and then measure this distance. This is the length of segment DB prime, and notice those two are the same. That's not going to change. So I'll go ahead and construct this segment, and the minimum distance then is going to be this length of AD, 5.31 plus the 9.56. So if I go back to point C and start moving this around, I can look at that number compared to, calculate this. So AD plus DB is that. So 14.87 is the minimum distance I'm getting. To move point C around, I can get back to that 14.87 once I'm right there, and then it starts going further away from that. Again, the reason why this works is because the shortest distance between 2 points is a straight segment. So from A to this reflected point of B prime, the shortest distance is going to be this. Since this segment is equal to this segment, and the segment AD doesn't change, AD plus BD is the minimum when we reflect that across. Now another option is if we were to take point A and reflect that one. So I'm going to mark the mirror, transform, reflect. So here's A prime. If I were to construct segment B to A prime, it still goes through that same point. So it didn't matter which one you reflected, you're still going to get that minimum distance. Hope that helps.